All right, guys, we're going to dive a little bit deeper into fractions today, and we're going to look at equivalent fractions. We have reviewed this and done lessons on this in class, so I just want you to pay very close attention to this review and remember the vocabulary that we looked at yesterday, with numerator being on top, denominator being on bottom, and that fractions are parts of a whole or of a whole set. All right, so first, what are equivalent fractions? Equivalent fractions are two fractions that are the same size or at the same point on a number line. So they are equal to each other in the amount of space that they take up. All right, to be equivalent, both fractions have to take up the same amount. Remember that all parts have to be equal when you draw this out, and that they have to take up the same amount of space to be equivalent. So let's look at this chart. 2/4 and 1/2 are equivalent because they both take up half of that circle. Notice that they are drawn so that they take up the same amount of space inside the circle. If you look on this side, we have 1/4 and 1/2. 1/4 and 1/2 do not take up the same amount of space. 1/4 is smaller, so they are not equivalent. The same thing applies for 1/2 and 4/8. They can split these in different ways diagonally as long as it takes up the same amount of space. Those two are equal because they both take up the same amount of space inside that square. On the non-equivalent side, 1/2 and 1/3 are not equivalent. First, they did two separate partitions inside, two different ones, but they did take up the same amount of, they use the same size shape when they drew it out, but it does not take up the same amount of space on the inside. So 1/2 and 1/3 are not equivalent. All right, remember that equivalent fractions do not always equal 1. They do not always equal 1 whole. Okay. So let's look at number lines, because they've also used number lines and a tape diagram as our examples. So you don't have to draw it out this way. You can draw a tape diagram or a number line. You just have to be sure that you are making the same size tape diagrams and partitioning it correctly, and that your number lines are the same size and partitioned correctly. Notice that they did 3/4 and 6/8. 3/4 and 6/8 are equivalent. On this side, they did 1/2 and 1/3 again. 1/2 and 1/3 do not fall on the same spot, so they are not equivalent. 1/2 and 1/5 are not equivalent. 1/2 and 3/6 are equivalent. Remember, on our tape diagram, we label each section as 1 and then whatever our denominator is, 1/6, 1/8, 1/9, so that we know we have all of our partitions. All right, equivalent fractions are fractions that show the same amount in pictures but use different denominators and numerators. You can use pictures or models or number lines to show equivalent fractions. We've done this in class. We've used pictures and we've used number lines and we've used tape diagrams. So if you look at their examples on their chart, they give us 2/6 and 1/3. 2/6 and 1/3 take up the same amount of space. They also have 4/8 and 1/2. 4/8 and 1/2 are equivalent. They take up the same amount of space. All right, this is an example of a fraction wall, just like we had in our classroom on the wall. This chart is just a quick guide to show you how some of these fractions are equivalent. Notice that they all take up the same amount of space, so you can easily look down and see which ones line up. So as we look down this chart, we can notice that 1/2, 2/4, 3/6, 4/8, 5/10, and 6/12 all hit the same spot. So 1/2, 2/4, 3/6, 4/8, 5/10, and 6/12 are all equivalent to each other. Remember, to be equivalent, they must take up the same amount of space. So if you're drawing these in a picture or a tape diagram, they must be drawn to the same scale, which means they're the same size and that their partitions take up the same amount of space inside that shape. All right, another way to find the equivalent fractions is to multiply the fraction by the same number. So and this is a new concept. So if I'm going to find an equivalent fraction that is bigger than the fraction that I have, I'm going to want to multiply the numerator and the denominator by the same number. So first I'm going to pick my fraction. So I'm going to pick 1/2, and I need a fraction that is going to be equivalent to 1/2. So I'm going to multiply my numerator and my denominator by 2 because I wanted to pick the number 2. So 1 times 2 is 2. 2 times 2 is 4. So 2/4 is equivalent to 1/2. And I know that because I've multiplied them by the same number. Okay. So if I did 3/6 and I wanted a fraction that was equivalent to 3/6 that's bigger than 3/6, I can multiply by 2. And I could get 3 times 2 is 6. 6 times 2 is 12. 6/12 would be equivalent to 3/6. I could also take 3/6 and I can multiply by 10. So then I would get 30/60. 30/60 is also equal to 3/6. So remember, there are 3 steps to using multiplication to find another equivalent fraction. Figure out your fraction, whether it gives you one or you're picking one. Multiply your numerator and your denominator by the same number. So if you're going to multiply the numerator by 2, you need to multiply the denominator by 2. And then the third step is to write out what that equivalent fraction is. All right. Now we're going to look at using pictures to check equivalent fractions. So just like we talked about a couple of slides back, you can draw out those tape diagrams and check your equivalent fractions to make sure that they are correct. Or you can draw it out in pie form. So remember, if you're using these pictures, you have to draw them to the same scale and partition them into the correct number based on the denominators. So if I need to partition into fourths, I do not need 4 lines. I need 4 sections. So I need 3 lines. So if you look here, they've partitioned into fourths. So they partitioned 1, 2, 3. That gave them their 4 sections. Same thing with eighths. They have 7 partition lines. That gives them 8 groups. So if I look at, this is my 1 whole because it's 1/2 plus 1/2, 1 whole. 2/4 equals 1/2. And 4/8 equals 1/2. They are shaded in because they equal 1/2. All right, using a number line to check your equivalent fractions. We use this the same way as we do tape diagrams. So we would have to draw our number line, partition our number line. And remember, when we draw this number line, we're going from 0 to 1 for a lot of these fractions right now. We can go past 1, but right now we're just going to look at 1 for our answers. So 0 to 1, because 1 is 1 whole. Partition it by however many you need. And remember, just like we said on the last one, if you're partitioning into fourths, you do not need 4 lines. You need 3 lines because it will give you 4 sections. All right, step 3 is to compare which ones fall at the same place on the number line. So we're going to look again at 1/2. So we have drawn them all to the same size, and we've done our neatest work and done it in a section that matches all the way across. It's the same length all the way across in between our numbers. So 1/2, 2/4, 4/8, 8/16. all equal each other. They're all equivalent because they all fell right at the middle of that number line. All right, so this is also a new concept to us. So we can also use multiplication to check our equivalent fractions. So when we use multiplication to check it, we have two steps. Our first step is to write our fractions with an equal sign in the middle. So they have written them out. Then you're going to multiply diagonally. Diagonally means you're going to go across, like from top to bottom across, like an X. So the numerator on fraction 1 is going to multiply by the denominator on fraction 2. The denominator on fraction 1 will multiply by the numerator on fraction 2. You can draw these circles around them so you know where you're multiplying, and then just write the number out from it. So 1 times 6 is 6. 2 times 3 is 6. 6 does equal 6. So 1/2 and 3/6 are equivalent. So if both of these numbers that you multiplied out are the same, that means that those fractions are equivalent. All right, so let's review really quickly how to check equivalent fractions. So we just went over these multiplication ones. These are called cross multiplication. You don't have to worry about knowing that term right now. Just know that when you are using multiplication to check it, that you're multiplying across in a diagonal pattern. So numerator to denominator, denominator to numerator, and you're seeing if they're the same. If they are the same, so 8 times 3 is 24, 12 times 2 is 24, they are equal. So 8/12 is equivalent to 2/3. If you're using a fraction on a number line, please make sure that you are doing it neat. You are partitioning it as close to perfect as you can, and you are making sure that you are making your number lines all the same length. And make sure when you partition it, if you're doing eighths, you partition with 7 lines. That gives you 8 sections. If you're doing pictures or tape diagrams, same thing. You need to split it into partitions. Your partitions all need to be the same size. And you need to make sure that when you draw your shape or your tape diagrams, that they are the same size. Otherwise, it's going to be real tricky on how to figure out if it's taking up more space or less space. So make sure you're as neat and as close to the same size as you can get. All right, it's that time. Go back and do your Google form. Make sure you hit submit at the end. You got this. You can do it. When you're finished, I need you to practice on Splash Learn. All right, go do it.